Good morning all. I am Dr. Dhondiba Vishwanath, Associate Professor of Chemistry, Government Women's College, Kalburgi. Today I am going to discuss about session number 13 and the topic is basic concept in organic chemistry. In this topic, I have to discuss about nomenclature of organic compounds. Now, while naming the organic compounds can be named in two systems. One is called as a common name system, another one is called as a IUPAC name system. We have to discuss about there is a detail about IUPAC name system. Actually, the common name system is given by depends on the history of the compound, sources of the compound, properties of the compound, and from that the name is given, and that name is very familiar with the particular area only, and beyond that particular area we cannot be that name is not familiar, and therefore the confusion will be takes place, and that confusion is removed by using a IUPAC name system. For that, organic compounds are systematically named in accordance with that is a IUPAC system. The main advantage of IUPAC name system is there is only one name for any particular compound. Actually, no, IUPAC in common name system, one name compound having a two structures and one structure having a two name can be possible. That's why that common name system is familiar with the limited area, but that limitation is over. It is removed by that is a IUPAC name. In throughout word, the particular compound only one name having a particular compound or structure only one structure and that having only one name. Therefore, the IUPAC name is very familiar. For naming the particular compounds, the certain rules we have to follow. The first basic rule is followed that the first rule, the longest possible continuous chain of carbon atoms. This is the actually select the longest possible carbon chain containing that is a long chain and it is the maximum number of carbon atom and that represented as a parent chain. For example, in structure given below, that is I show that is the structure here. This compound is there. This chain, no, how it is select? Either this compound may be vertically or that is horizontally written, but you have to choose such a that it should be a longest. Suppose we are taken that is a here. This is the 1, 2, 3, 4, 5. This is the suppose we are selecting that is a left to right numbering. Therefore, it is say that is a only 5 carbon atom. Again, suppose we are selecting that is a from here to here. 1, 2, 3, left side 4 only carbon atoms, but 1, 2, 3, 4, 5, 6. Therefore, we are selecting like that is a from this side to bottom to right side. This is the rule follow, or otherwise we can be follow that is a right side to bottom. This also follow, but actually this rule is ruled out after that is another rule. Therefore, here for that compound, particular name is that is from bottom to up and then go to that is right. Therefore, 1, 2, 3, 4. This is the parent name, and parent name is nothing but it contains a 6 is coming. Therefore, it is called as a 6 carbon containing that is it is a parent chain. And here only another carbon atom is that is methyl group is there, that will be act as a substituent. This is the first rule. Therefore, however we are selecting naming the compound, we have to select the possible carbon chain such that it should be a longest, and other that is the substitutions or other carbon atoms taken as a substitution, and that is parent name is nothing but it is a longest chain. Second one, if there are 2 or more carbon chain having the same number of carbon atoms, the one which carries the largest number of substitutions is selected as a parent chain. This is the another rule. For that we have to say that is a here. This is the one compound is there. Here this is the this one chain is there, another one chain is there. Here 1, 2, 3, 4, 5. This is the here substitutions. How many substitutions are there? Here at 2 position one substitution is there. Another at 3 position another substitution is there. Therefore, we say that is a 2 substitutions. Large number of that is substitutions are here. But here how it is? Suppose another this compound we have to give that is naming as that is 1 prime, 2 prime, 3 prime, 4 prime, 5 prime. Suppose we are selecting this is the only one substitution. Therefore, this compound having a one substitution, that is isopropyl group is there. But here in this compound, one is methyl, another one is ethyl group is there. Therefore, two substitutions are there. Therefore, numbering should be like that you have to give, not that is like this. Therefore, this naming is ruled out. This will be a correct one. Now coming to the third one. If a double bond or triple bond is present in the molecule, the present chain must contain the double or triple bond. Parent chain, suppose the compound contains double or triple bonds are there, then the chain should be must be present or considered as it contains a double bond or triple bond. If even it is not longest chain. For example, here we have to say that is this compound is there. This is the suppose we are take there is a here 1 2 3 4 5 6 7 carbon atoms. Suppose we are beginning from here or from here 1 2 3 4 5 6 7 is there, but here double bond is considered as double bond or triple bonds are there, then it should be considered in the parent word parent chain. You should not be taken as a substitution. Therefore, the numbering should be a here, or that is a selecting the longest possible chain is nothing but here from left to 1 2 3 4 5 6. Even though it contains this chain is the 7 carbon atom chain, and other here it is the here 6 carbon atom chain is there. Others is nothing but 7 carbon atom is there, but 7 carbon atom is not required because this in the 6 carbon atom chain, one that is a double bond is there. Therefore, double bond should be considered in the parent chain. Therefore, the numbering or that is selecting the longest possible chain should be taken as like this, and this group that is a propyl group will be there. This is the considered as a substituent. Next, fourth rule is if the molecule contain more than one double bond, more than one double or triple bond, then the parent chain should include the maximum number of bonds, even if it is not longest chain. For example, now this compound you have to take. Again here, suppose I already take that is double bond or triple bond should be considered as a parent chain, and others that is even the single bond it should be a longer, no, that is considered as a substitution, and that is not considered as a parent one. Their parent chain. Therefore, here 1 2 3 is there. Here 3 4 5 6 7 is there. Again here double bond. Here 1 2 3 4 5 6. This is the 6 carbon. It is 7 and this is 5. That is 7 and that is 6. But it contains a double bond at one position, and that is at 4 position. Double bonds are there, and these double bonds are considered as a parent chain. Next, fifth rule is nothing but if the molecule contains functional group, the parent chain got the include. The parent chain has got include the functional group even if it is not a longest chain. For example, here suppose here this means that this carbon chain here how many carbon atoms? Suppose 1 2 3 4 5. This is the carbon chain. It is a 6 carbon atom chain, but if it is functional group, then you have to consider as the functional group as a parent chain, means you have to number from here. This is methyl, that is a carboxylic acid group carbon atom 1 2 3 4, and this is the ethyl group should be considered as that is a substitution. In that is sixth one, in polyfunctional compound it should be ensured that the parent chain includes the maximum number of functional groups, including the principal functional group. You have to here in polyfunctional compound, it should be ensured that the parent chain includes the maximum number of functional group, including the principal functional group. For example, here you have to say the here this is polyfunctional group, means you have to take there is a one here. This is a functional group is there one, again here one two, that is a here it should be a this is carboxylic acid 1 2 3 4, and here that is the alkane is there, no, this is it is a ethyl group is there, that should be taken as a, that is substitution. Actually this is the not a polyfunctional group, one is ethyl group, another one is carboxylic acid group, this is the only one functional group. If it is suppose we have to take as a suppose we have to take another, that is COH group here, the polyfunctional means here one COH group is there, another one is suppose a CHO group is there, then you have to take that is a 1 2 3 4. 4 means the two substitutions group should be taken as a longest chain, and others, that is the non-functional group, should be taken as a substitution. This is the main rule, and that is sub rule I have taken, that is selecting the longest possible carbon chain. Okay, how it is selecting, that I have explained. Now coming to that is the second rule, that is the main second rule is nothing but numbering the parent chain. Parent, after that is selecting, once we have to selecting the parent chain, and that should be written as a horizontal manner, then next duty to name the compound. The second rule is nothing but you have to name the carbon chain, that is the parent chain. First one is again in this, no, some that is the rules are there, sub rules. First one is goes to, if the parent chain carries the substitution or functional group, the chain is numbered starting from the end which is closer to the substitution or functional group as they may be, so that the number should be used to position of the substitution functional group lowest. That is, it is called also called as a lowest number rule. Lowest number rule means, for example, I take that is a one example here. This is the by this rule can be explained by using a this compound. Here we can be numbering this chain, actually selecting the longest carbon chain means here 1 2 3 4 5 6. Suppose you are taken that is 1 2 3 4, this is the 5, but it is this is the longest possible chain, this is the taken as a like that, and this is the methyl group is act as a substitution group, and this is the longest possible chain over. Then after that is it contains the 6 carbon atoms. Now number this chain by two ways, one is from left to right and right to left. Suppose we are going to, that is from left to right, what happened here, it should be 1, it should be 2 3, then 4 5 6. At that is a 4 carbon atom, the methyl group is the substitution is getting, therefore at a fourth carbon atom of carbon chain it is getting the substitution. Now coming to that is a right to left, you have to go into the right to left means here 1 2 3 4 5 6. This indicates that at from this rule from right to left, at third carbon atom the methyl group is there, therefore this is the correct rule, that is the numbering, and earlier is nothing but it is a ruled out, because that is right to left it is coming at that is 4 carbon atom, and right to left it is coming to that is at third carbon atom, and from left to right is getting that is at that is a fourth carbon atom, therefore fourth carbon atom getting it is ruled out. Now this is the that is the numbering. Then second rule it say that if there are more than one substitution in the parent chain, more than one substitution is there, then the numbering of the carbon atom is done in such a way that the sum of the number used to locate them minimum, and this called as a lowest sum rule. Earlier was nothing but it is the lowest number rule. This is the lowest number rule, and second one is it is nothing but lowest sum rule. Lowest sum rule will be getting, the sum will be take as a minimum, and that will be considered. For example, here suppose I take that is a here example. Now here This is numbering from that is left to right. I say that is the numbering of this compound. Here two or more substitutions are there. Here one methyl, another methyl, here methyl group. Right, these are the different carbon atom. The methyl group, three methyl groups are attached. Therefore, it is more than one substitutions are there, or it contains that is a three substitutions groups are there. Now here, first one is 1, this is the 2, 3, 4, 5, 6, 7. Now sum, you have to take that is the sum. Here 2 carbon atom, 2 plus this is the 3, 5 plus that is 6. How many there? The 5 plus 6 means it is the 11. Correct. Now this is the 11 is getting that is a 2 plus 3 plus 6, it is getting that is 11. That is the total sum of that is substitution carbon atom, position of the carbon atom getting that is 11. Now you have to go to that is the other hand from right to left. Here 6, this is the, here suppose we have to take that is 1, this is the 2. At 2, one substitution is there, that is a 2. This is 3, 4, 5, 6. Means from right to left, at 2 carbon atom is there, again at 5 carbon atom is there, and again 6 carbon atom is there. That there are the 3 substitutions group are there. Therefore, 2 plus 5 plus 6. How many there? That is a 2 plus 5 means 7, 7 plus that is 6 means 13. Here we have written that is first one, that is a 2 plus 3 plus 6 from it is equal to 11. It is left to right already given, and from right to left, that is it is getting 2 plus 5 plus 6, therefore 13. And among these it will be 11 will be less, therefore the left to right is the correct numbering of that is a compound. Next, third rule, if the nitro, if nitro NO2 or nitroso NO or halo means that is chloro, bromo, iodo, whatever may be, these groups are not regarded as a functional group. These groups are not at all considered as a functional groups. Okay, therefore they, in the IPSC naming, they are only considered as substitutions. If these compounds, that is a nitro, nitroso and halo, these groups are present in the substitution compound, substituents group or compound, they are considered as a only substitution but not a that is a functional group. When two such groups are present, numbering is done from the end, which gives the lowest number of group coming first alphabetic order. For example, we have take that is a here this is the this compound is there. Now here bromo and that is iodo, these are not a functional groups, and therefore we are not considered as a parent chain. Now here the problem is the getting that is here the nitro group is present at the first this carbon atom. Suppose we are going to the number that is this chain, this is the 1, this is the 2, this is the 3, correct? And from left to right, this is the 1, 2, 3. You have to now how it is giving that is a numbering from right to left or left to right. This can be say that is you have to arrange this substitution group, that is bromo and another one is nitro. Bromo and nitro, these group arrange in the alphabetic order. For that the bromo will become first. Therefore you have to number such that the bromo group comes at the first carbon, that is the lowest carbon atom. Therefore we have to give that is a 1, that is a 2, here it is bromo 1, that is a 1, this is the 2, then this is 3. First bromo, then nitro. Therefore the numbering should be takes place here from 1 to 3, but not that is a 1, 2, 3. And this is the rule is say that is about this. And next fourth rule is say that is in a polyfunctional compound, one of the functional group is chosen as a principal functional group, while the rest are treated as a substitution. In polyfunctional group, so many compounds are there. So the double bond is there, triple bond is there. Again, we have to say that is a that is aldehyde group, carbolic acid. These groups are there, no? Therefore, first preference gives to that is the first. The order of the decreasing order of the preference to the lowest carbon atom is principal functional group, means the carbolic acid, alcohol, like that. then double bond, triple bond, and substitutions. You have to order these for these polyfunctional compounds. Next, third main rule is there, giving the parent name. How to name the parent chain? After first you have to select. First rule is nothing but it is first rule. Actually, broadly, that first rule is select the longest possible carbon chain containing a, that is a functional group. That should be selecting the longest possible carbon chain. Right. Second rule is nothing but number the carbon chain. The second main. Again, that is the second main or first main contains, that is a sub rules are there. That is keenly we have to decide how to naming, that is how to select the longest possible carbon chain for first rule, and second for second rule, how to number the parent chain either from left side or right side. That is sub rules are there that I have already discussed. And third main rule is nothing but giving the parent name. This now third, this is the given for giving the name. No, here the parent name is nothing but the same number of alkaline containing the same number of carbon atom. Suppose we are getting there is a 6 carbon atom chain, therefore 6 carbon atom is hexane. Hex we have to write, that is a hex, correct. The name of this compound is hexane. Or suppose the 7 carbon atom is, that is a heptane. Suppose 4 carbon atom is pentane, that is a butane. If 5 carbon atom is there, that is a pentane. If 3 is nothing but propane, like that. This will be a corresponding the alkane you have to name. But suppose for example, this compound is nothing but it is a 6 carbon atom chain, therefore it is called as a hexane. You have to write. This is simply you have to say that is a parent word is, that is hexane. Actually, this is the IUPAC name contains, that is a, I have not said that is a earlier, that is a, it is contains, that is a 3 words actually. One is, that is a root word means that is a parent name. Second one is suffix means after that is parent or root word which is getting no, that is called as a suffix, and prefix means substitution. Therefore that is any organic compound contains, that is 3 words mainly. One is called as a root word, second one is suffix, third one is, that is a substitution. And the root word is concerned to, that is a number of carbon atom chain. That is same, say that is here giving the parent name is 6 carbon atom means hex, it is getting hex. And ANE means suppose it is contains a carbon single bond, therefore ANE you have to write, that is hex plus ANE, hexane. Suppose one double bond is there, that is a hex plus ENE, therefore hexene will be there. And suppose carbon triple bond containing, that is a 6 carbon atom is there, therefore it is a hexane will be there, like that. Or suppose pentene, octane, like that. There are so many compounds we have to say, that is a deeply we have going. Next, after that, another rule, that is a fourth rule, is nothing but indicating the substitution. How it is a numbering and a name indicate how it is a indicate, that is a substituents, because it contains, that is substitutions will be there, root word will be there, and suffix. Suffix means that is functional group, that is the main function group. Okay. Therefore, this is the fifth, that is fourth rule is there. In the substitutions are side chain attached to the present. That is substitution means nothing but it is a side, that is a side chain of the parent chain. The side chain groups attached to the parent chain is called as a substituent. It could be alkyl group or aryl group or any earlier functional group, nitroso, nitro or halo. These are the that is considered as, that is a substitution. How it is written? The first rule says that substitutions are indicated as a prefixes. Prefixes means before the root word, main root, that you have to prefix. Their position on the parent chain as also shown. For example, then there is a, for example, this compound. According to this is the first rule, you have to select the longest possible chain. Carbon chain means 1, 2, 3, 6 like that. Then number will be there. That is a 1, 2, 3. We should not be right from right to bottom. How it is 1, 2, 3, 4. It will be getting, that is 4 from right to bottom. but here bottom to right means it is getting 1, 2, 3. Therefore, it is second. The naming is that is this bottom to right side, bottom to top, and then right. This is the correct one. 1, 2, 3 will be there. Therefore, 6 carbon atom is hex. Here contains a only single bond. Therefore, hexane. Hexane will be there, and this methyl group is act as a substitution, and that substitution name is nothing but this is the one carbon atom is there. Therefore, it is called as a methyl. Right, along with you have to the position of the carbon atom is given. Therefore, 3 methyl hexane is the name of this compound. Therefore, we have to say that is a 3 methyl hexane is the name of this compound. Next rule we have to go, that is a deeper side. When two or more different substitutions are present, here only one substitution is there, that is methyl. If it is more than one substitution group there, then you have to go to that is a they can be arranged in the alphabetic order. Suppose bromomethyl is there. Bromo you have to first utter, then followed by methyl. If this like you have to say here. So suppose consider that is this compound here, this compound, and numbering should be takes place from here. 1, 2, 3, 4, 5, 6 will be there. Then this numbering. Therefore, this will be what is the name of this compound. Here methyl will be there, one carbon atom. At third carbon atom, that is ethyl group is there. Ethyl will be comes in the first alphabetic order first. Therefore, ethyl you have to give. Therefore, along with that is the position of the carbon atom location means that is a 3 ethyl, 2 methyl, and this is the hexane is the name of this compound. Therefore, simply we have to say that here 3 ethyl, 2 methyl, that is hexane is the name of this compound. Next, another rule. Next, deeper we have to go. When two or more identical substitutions are present, identical means 2 methyl group or nitro two groups are there, or 3, 4. If it is the same group repeated twice, therefore you have to write dia. If 3 times, tri. If that is 3, tetra. Then it is a penta, hexa, hepta, whatever may be you have to write. For example, this compound is there. Here 3 substitution groups are there. That similar methyl. 1, 2, 3 methyl groups are there. Then you have to write that is a numbering is same, that is according to rules earlier I have explained. The 2, 3, 6, and that is 3 times repeated, that is the trimethyl. 3 times repeated, therefore trimethyl. This is the 7 carbon atom, therefore it is called as a heptane. Heptane is it is contains only carbon single bond, therefore it is a heptane. Therefore name of this compound is 2, 3, 6, that is a trimethyl, that is heptane is the name of this compound. Next, suppose we have to consider again here under the prefixes di and tetra, di and tri, tetra, etc. No, these cannot be considered as that is alphabetic order. You have to say that is if di means it come, that is earlier the first in the alphabetic order instead of that is tetra, tri. You have to these letter di, tri, tetra. You should not be considered as in alphabetic order. But methyl, ethyl, propyl, di, that is a di you should not be say, that is only methyl group is there 2 times means methyl should be considered as a that is a ethyl means ethyl should be considered 2 times ethyl group is repeated, then diethyl you have to say like that. Therefore, these are di, tri, tetra, it not considered as a alphabetic order. Okay. Now, for example, here ethyl group is there, here ethyl group is there, here methyl group is there. Okay. Therefore, the ethyl will become the di is there, di will be a diethyl it come, and that is a methyl will be a come. Therefore, what is that? Actually, this compound here actually, therefore here 1. Okay, here actually like suppose we are numbering no 1, 2, 3, 4, 5, 6, 7. Therefore, here actually 2 methyl groups are there, 1 ethyl group is there. Now, ethyl group, ethyl, another one is methyl. Dimethyl you should not be considered. Di means it comes that is first in the alphabetic order before that is ethyl, but therefore di you should not be considered. Only you have to consider as a methyl group. Methyl group. Therefore, the here 5 ethyl, 3 comma 3 dimethyl, that is a 7 carbon atom. Therefore, heptane is the name of this compound. This is the another how it is the naming and how it is substitution group are there. Now next another that is the last that is step is nothing but indicating functional groups. Indicating functional groups. The functional groups except amino and ether. These the except functional groups no. Usually functional groups is written as the suffix. Substitution written in the first of the root word, and functional group should be written on the suffix means right side. The substitution group should be earlier, that is the left side, then followed by that is the root word, and lastly that is the suffix means it is a functional group. And here functional group except that is amino group, we have to say that is amino group, it is a functional group. Actually we are considering that is organic chemistry. Ether also that is functional group, but except this group ether and amino group, you should not be except these we have to consider. Therefore except ether and amino indicated by the along with that is parent chain. The suffix presented a few common functional group listed below here. Now therefore here except these that is the what is that amino and ether, except these other functional groups you have to consider. Now suppose carboxylic acid COH group there, therefore the suffix should be a oic acid. Oic acid. Suppose aldehyde, that will be written as a Al. Al. If it is a ketone is group there, 1 you have to write. If it is alcohol is there, OL you have to write. These are the functional groups that will be written as a suffix. But amine it should not be written as a amine. Okay. Amine and that is ether. We cannot be considered as that is a functional group. It is considered as a substitution. Okay. These suffixes put in the places of last letter of the parent name. Okay. Parent name means saying that is a carbon atom chain after. A carbon double bond or triple bond is donated by donated by the suffixes ene. If the carbon double bond is there, that will be represented as ene. If carbon triple bond is there, that should be written as a yne, that is end, which are put in the place of that is the last letters. Okay. For nitrils the suffix is the nitrile. Suppose nitrile means cyno group. No, CN is there, that you have to write as a IUPAC name, that is a nitrile. Nitrile you have to write, and that is if it is a functional group is act as a CN, therefore it is written as a nitrile. If it is a substitution is there, therefore you have to write that is cyano. Okay, this is the there. Again the same, when the same groups are repeated, the diatribe can be same you have to use. For that, from that we have to just naming this compound. Suppose take the example this. Here this carbon atom, no? This is the carbon atom. This is the functional group, no? The functional group actually, no, it is not taken as that is a substitution group, but from this carbon atom you have to number. This is carbon atom 1, this is the 2. If these groups, no, the methyl, no, it should be at the long, that is the end, no, end or beginning. The carboxylic acid it will be present at the end of the carbon chain, or that is the beginning of the carbon atom chain. Therefore, that carbon atom should be written as a 1. Here, this is carboxylic acid carbon is there, that should be written as a 1. You should not be start from here. Here 1, 2, you should not be right. But from the carboxylic acid carbon atom, you have to give that is a number 1. 1, 2, 3, 4, 5, 6. Therefore, this is the 6th. Therefore, it is called as a hexane. But this is the functional group is nothing but oic acid. No, the drop E and add oic acid means hexane plus oic acid. Hexane drop E plus add oic acid. Therefore, hexanoic acid is the name of this compound. Again, suppose this compound is there. This is aldehyde group. Aldehyde group, it should be comes from that is a end or beginning of the carbon atom. From beginning, the carbon atom 1, 2, 3, 4. This like you should not be give that is a numbering from here 1, 2, 3 like that. Okay, the aldehyde carbon atom should be a give that is a number 1. Again, carbonic acid carbon atom should be given that is a number 1. Okay, 1, 2, 3, 4. Therefore, 4 carbon atom. Therefore, drop E and add 1. That is a butanol. This is the Al is the suffix and root word is nothing but butane actually. Drop E, add Al. Therefore, butanol. Butanol is the name of this compound. Similarly, you have to work out these compounds. Here, this is the ketone group is present. Ketone, that is the one you have to write. That is numbering should be takes place from 1, 2, 3, 4, 5. 5 is there. Therefore, 5 carbon atom. At 2 carbon atom, ketonic group is there. Therefore, pentanone. That is a pentanone. We have to say that is a pentanone. Or pentane, drop E, add to 1 you have to write. That is a pentanone. 2 pentanone is the name of this compound. Similarly, we have to say that is the alcoholic group here. Alcoholic group. Therefore, the this is the you have to consider as a substitution. 1, 2, 3, 4, 5. 5 carbon atom chain. At 2 carbon atom, that is the OH group is there. That is a 2-pentanol is the name of this compound, or 2-pentanol. That is this is the OH group is the present at this. Therefore, 2-pentanol is the name of this compound. Another one is say there is here the this compound, the double bond is there. There is hexene. Double bond, there is a ENE will be there. Here this compound containing the 6 carbon atom chain. Therefore, hexene, but it should be a double bond is present at between that is 2 and 3 means, and beginning there is a lowest number is nothing but 2. Therefore, 2 carbon, the 2 hexene is the name of this compound. Or hex 2 in we have to also write. Similarly, there is a YNE. Triple bond means Y, and there is a 2-pentyne. Here 5 carbon atom chain is there. That is a 2-pentyne is the name of this compound. Suppose this will be a here. Again, propane will be no propane. That is a propane. That is means here cyano group. There is a nitrile compound is there. CN will be there. You have to number that is a carbon atom of that cyanide group or nitrile group. That is as a 1. Similar to like there is a carbonic acid and that is a aldehyde group. No, that carbon atom we are giving starting from that is a that carbon atom 1, 2, 3. Similarly, you have to give that is a numbering from here. That is a cyano compound. Therefore, 1. This is a 2, 3. Therefore, this is the 3 carbon atom. That is a propane. That is 3 means propane, and you have to write that is a simply nitrile. Propane nitrile is the IUPAC name of this compound. Next, another that is a sub that is further we can detail go. In case of the carbonic acid aldehyde groups, nitrile as a functional group always appears as the first position. Usually these no, we have say that is a here the carbonic acid at the appear as a 1 carbon atom, aldehyde group at 1 carbon atom, cyano at present 1 carbon atom. Therefore 1. Hence the position of the functional group is the compound is not indicating as a 1. Actually no. Therefore this for that 1 we should not be write that is a hexane 1 oic acid we have not written. Therefore butane 1 nol we cannot be written, or propane 1 nitrile, because these are all are present at the 1 carbon atom, and therefore first carbon atom means it is functional. The numbering should be taken from that carbon atom. Therefore, we are not written that is a 1 whatever numbering we are not written. Okay. Next, to indicate the position of the multiple bonds, the number of the carbon atoms proceed by the multiple bonds. That is the lowest number is considered. To indicate the position of the multiple bonds means a double bond or triple bond. The proceed with that is a atom that is a multiple bonds. That is the lowest number. Lowest number we have to consider. Double bond will comes that is first carbon atom. Lowest number that you have to number. Okay, that 2 butene or 2 pentene double bonds. Here we are not written that is a 1 oic acid or 1 al we are not written, or 1 nitrile we are not written. But here you have double multiple bond here no. If it is 1 is there, you cannot be written. If more than there, that is 2 butene 2-pentene or 2-pentyne, 5-pentyne. We can write that is like that. That should be written as the number. Okay. Next, if the amino groups and their derivative are not that is given as shown as a prefixes, but they indicate as a prefixes. Amino group, suppose we are not it is a the functional group, but it is not written as suffix, but it indicate as the prefixes. Suppose here primary amine, should be this like group, therefore amino, and this is called as a prefix. And NHR, that is suppose R any group, that is methyl, ethyl, whatever may be, N alkyl amino. Suppose R is methyl, N, that is a methyl amino. You have to write. If R2 is nothing but there is a R means it is a methyl group is there. Therefore di, that is NN di methyl amino, or diethyl amino, or there is a N ethyl amino, like that. Therefore, these are we have to write. For example, this compound is there. Therefore, numbering should be takes place from here. 1, 2. You should not be takes from here. 1, 2. You should not be right. Here longest is 1, 2, 3. And therefore, 2 amino. 2 amino. It is a propane, and this is the propane. Therefore, simply say that is a 2 amino propane is the name of this compound. And about we are saying that is the amino as well as ether we are not taken as a functional group. I have already explained, and why we are not explaining this I have discussing here. The ethers are named as alkoxide of alkanes. The ethers are named as alkoxides of that is alkoxy alkanes. The longer chain is chosen as the parent chain, while the shorter chain along with there is oxygen atom is considered as a substitution. For example, here this the ether group is there. Therefore, here the long here left side here oxygen atom, no, this is the oxygen is the this is the function group. This is nothing but ether group. Left side how many carbon atoms are there? 1, 2 carbon atom. Here right side 1, 2, 3 is there. Therefore, this is considered as a 1, 2, 3. Long chain you have to give the numbering, and short chain is written as a prefixes. Therefore, you have to write there is a, here ethoxy. This is the 1, that is a 2. This is the ethyl group. This is the from this is ethoxy, and this is the called as a propane. Therefore, ethoxypropane is the name of this compound. Suppose we say there is a another here we have to say there is another methyl group is there. Here same group is there, propane, and here propane. Therefore, propoxy propane is the name of this compound. Like that, the longer chain should be considered as a end, and shorter that is a carbon chain along with alkoxide, that is a oxygen group, that you have to say that is alkoxide. Therefore, here ethoxy there. Suppose here only one methyl group is methoxy propane will be there. Methoxypropane, ethoxy propane, or if it is butane is there, 1, 2, 3, 4 will be there. Therefore, ethoxy, that is butane will be there. This is the name of this compound. Therefore, this name is nothing but that name of the compound is ethoxypropane. Since the alkoxy always that is appear as a first position, and the position is not indicated. Okay. Next, that is the last rule, that is in polyfunctional compound, one of the functional group chosen as the principal functional group of the remaining functional group are treated as a substitution. The principal functional group is chosen the order. Suppose principal chosen, no, that should be a carboxylic acid. First you have to write, give the preference, that is oic acid. Wherever that is carboxylic acid there, that should be must be oic acid. Then if it is aldehyde will be there, compared to aldehyde and carboxylic acid there, the aldehyde group should be taken as a substitution, and this should be called as a function group. If aldehyde and nitro, that is these three groups are present in the same compound, therefore this is the oic acid, and the aldehyde group and nitrile, no, these are act as substitutions. Okay. And ketones, these are the given that is a preference. Therefore, the function that is a main function group, principal function group should be first give the preference for that is a carboxylic acid, then aldehyde group, nitrile, then ketones, alcohols, amines, ethers, then triple bond, that is a alkyne, then alkene. This you have to give that is a order. For example, now prefixes. Suppose we say that is here one is compound, that is a carbonylic acid, another one aldehyde group in the same compound. The how it is say that is you have to give the preference for that is a principal functional group means carbonylic acid. Carbonylic acid means oic acid should be there. Oic acid will be there, and the aldehyde group is there, that will be act as a prefix. Prefixes how it is the for that is the aldehyde group, you have to write that is CHO group, that should be a formyl. You have to say that is a formyl, and that therefore it is CN is there. Instead of nitrile, you have to that is cyano. When it is cyano nitrile compound, nitro group is considered as a substitution, then for you have to written as a cyano. And keto, suppose you act as a ketone, and that is carbonic acid present there, therefore ketone group should be 18 as the prefixes, and this is written as a keto or oxo. Keto or oxo you have to write. Then hydroxy group, that is a OH group. In alcohol group, that is a hydroxy group, and OR, that is a alkoxy group. And these are the act as a substitution and the special name of this functional group. While these are the act as a that is a principal functional group. Functional group means it is aldehyde means Al will be there. Here nitrile will be there. Here 1 will be there. Here OL will be there. Here that is a alcohol, that is a ether will be there. That like here, but here alkoxide, this like will be written. And therefore so far we have discussed, this is the long that is a detailed topic about that is a nomenclature of the compound. Therefore so far I have discussed about the naming of the organic compounds. Just I say that is summary. The naming of the compound should be any compounds can be named in two methods. One is called as a common name system. It is also called as a trivial system, and it is due to present of that is a function of the compound or character or sources or occurrence, whatever may be. Suppose we say that is a Jaipur. Jaipur is there, no? Jaipur is also called as a pink city. This is the pink name. But in other than that pink, that is a Jaipur, no? Other area there will be another pink city will be there. Therefore, one name having a two city will be there. Therefore, it is avoided. Therefore, only that is a trivial name or common name. It is based on the source, history, that is character, whatever may be. Again, for example, acetic acid. It is occurred in acetum. Acetum means that is a vinegar. Therefore, acetum means vinegar, and therefore it is a remain that is given that is acetic acid. Formic acid. Formicus. Formicus means it is a red ant, and from red ant that can be extracted, that is acid, that is called as a formic acid. Therefore, from the source, from the history, from the character, they given that is name, that is called as a common name. And another is nothing but that is a IUPAC name. It is a very specific one. Only one compound having only one name, and only one name having only one structure. Therefore, it is a very, there is no confusion takes place at all. And therefore, it consists of that is a three main words. One is called as a prefix, root word, and suffix. Prefix is nothing but always substitution, and root word is nothing but always that is a carbon chain, and third one is nothing but last one is that is suffix. This is the functional group we have discussed so far. I hope you have already understand. Thank you.